In the previous parts, we did extraction of morphometric characteristics for the subbasins and for all study area basin, which included formal characteristics and topographic characteristics. And we arrive at the ninth characteristic in topographic characteristics, which is the hypsometric analysis. Where the hypsometric analysis or the hypsometric curve or the hypsometric curve in its calculation is based on the relationship between area ratio confined to specific heights of contours lines. It can be obtained by the following equation: hypsometric parameter equal relative height over relative area. In order to determine the stage the basin is in, Strahler divided the value of the hypsometric integration into categories as follows: 1, 40 or less represents the stage of aging. 2, 40 to 60 represents the maturity stage. 3, 60 to 80 represents the youth stage. Now we compute the hypsometric analysis or hypsometric curve, where we make a copy for hypsometric analysis. Then we go to the desktop and we make a folder in the name of hypsometric analysis. Then we go to the project in ArcMap. And we go to the dim layer that is cut for the study area, and it is titled extract dash fill 5, as we see, and in it we note the elevation where the low is 128 and the high is 3532, where we divide the elevation for the study area to intervals, and these intervals start from 200 to 3006 and 600, i.e. 35 interval. To do that, we go to the Arc toolbox, and in it we go to Spatial Analyze Tools, then to Reclass, and we choose Reclassify, In input raster, we choose extract-fill 5. We note that the elevation is divided into 9 intervals. So we divide the elevation into 35 intervals, where we click on classify. A window appears, and in it we go to classes and we type 35. Then we go to the method and we choose manual. Then we go to the break values, in which we define the intervals starting from 200, then 300, and ending with 3,500 and 600. That is the difference between the interval, and another is 100, as we see. If the errors appear, we correct them, as we see. When we finished entering the intervals, we press OK. The number of intervals appears, which are 35, which is 35. Then we go to the output raster and we specify the location for saving in the following path. Desktop, Hypsometric Curve, Hypsometric Analysis. Then we create a new file, new database, with the title Hypsometric Analysis. And in it we type the save name, where we make a copy for the save name, and we go back and open Hypsometric Analysis GDB, and we type the save name, then we press on save, then we press OK, and then a message appears indicating that reclassify completed. Then close. A new layer titled reclass-xtr1 appears. Then we go to the Arc toolbox, and in it we go to conversion tools. Then from raster, and we choose raster to polygon. In input raster we choose reclass-extr1 layer, and in field we choose value. Then we go to the output polygon features and we specify the location of saving in the file hypsometric analysis.gdb, and we type the save name. Then we press on save, then we press OK. A message appears indicating that raster to polygon completed. Then close. A new layer entitled raster T-RE reclass1 appears. The table of this layer contains the field shape area, and shape length, or the parameter. Then we make a right click on the grid code field, and we choose summarize, and in it we go to the shape area and we choose sum, and we make sure of the place of save. Then we press OK. Then we press OK. Then yes. A new table appears in the table of content titled sum-area. as we see, where this table contains 35 interval, and each interval has a specific area. Then we transfer this table entitled sum-area to desktop, where we go to our toolbox, and in it we go to conversion tools, then Excel, and we choose table to Excel. In input table we choose sum-area, then we go to output Excel file, and we specify the location of the save in the following path: desktop, hypsometric analysis, and we type the name of save area, then we press on save, then we press OK. A message appears indicating that table to Excel completed. Working on ArcGIS is now finished. Then we prepare an Excel file to perform the calculations for hypsometric analysis or the hypsometric curve that contains these fields, as we see. In the next part, we will continue to conduct the rest of the calculations for the hypsometric analysis or the hypsometric curve.